Welcome to the Deep Dive. Today we're jumping into Apache Spark. It's this really powerful engine that's, well, changing the game for handling huge amounts of data.
Absolutely. And our mission really is to give you the essentials, kind of a quick guide to its core capabilities.
Right, show you why it's something you really need to know about in modern data processing. We're pulling our info today straight from the Spark capabilities all-in-one document. Pretty comprehensive stuff.
It is. And the headline figure is always attention-grabbing, isn't it?
Oh yeah, get ready for this. We're talking potentially 100 times faster in memory and even 10 times faster on disk compared to, say, the older Hadoop MapReduce.
Which is just massive. Think about cutting down those read-write cycles.
Exactly. That's the key.
Yeah.
Imagine processing financial fraud checks, like almost instantly, or
Yeah.
big genetic analyses finishing in minutes, not hours. That's the kind of real-world speed we're talking about for big data problems.
And that speed really starts with Spark Core. That's the foundation. It's built for large-scale parallel distributed data processing.
So how does it get that speed advantage over something like Hadoop?
Well, traditional systems like MapReduce, they often had to write intermediate results back to disk between steps. Lots of slow I/O.
Right, that constant reading and writing.
Spark tries to keep as much as possible in memory across those steps. It drastically cuts down those slow disk cycles. That's where the big efficiency boost comes from, especially with large data sets.
Okay, so speed is the foundation, but Spark isn't just fast, it's also versatile, right? The document talks about these specialized libraries, like 4 pillars.
That's right. It's got a whole toolkit.
Yeah.
So let's say you have lots of structured data, tables, and the like.
Yeah, what does Spark offer there?
That's where Spark SQL comes in. It lets you integrate relational processing directly. It uses these things called data frames, and data sets, think of them as smart spreadsheets, basically.
Okay.
And you can query them using standard SQL or even Hive query language if you're used to that from data warehousing. Makes working with tabular data much more, intuitive.
Got it. So SQL for data that's, well, sitting still. But what about data that's constantly flowing in, live data streams?
Ah, yeah, for that, you need Spark Streaming. It's built specifically to process live data as it arrives.
Like sensor data or website clicks.
Exactly. IoT events, log messages, financial trades, you name it. It handles high throughput, it's fault tolerant, and it essentially chops up that continuous stream into small batches Spark can process really quickly.
Enabling those near real-time insights.
Precisely. Things that used to be batch jobs taking hours can now happen in seconds.
Okay, so we've covered structured data and streaming data. What about building intelligence, machine learning?
Yep, that's the third pillar, MLlib, Spark Machine Learning Library.
What's in the box there?
It's got a pretty comprehensive set of common ML algorithms, classification, regression, clustering, recommendation engines, that kind of thing, plus tools for building pipelines, feature engineering, model evaluation.
So it lets you apply machine learning directly to those massive data sets Spark is so good at handling.
Exactly. It makes large-scale ML much more practical and accessible. You're not limited by trying to run complex algorithms on data that won't fit on one machine.
Makes sense. And the fourth pillar mentioned is GraphX. Sounds specialized. What's that for?
It is. GraphX is Spark's API specifically for graph data and graph parallel computation. Think social networks, network diagrams, biological pathways.
Data where the connections are important.
Right. It extends Spark's core concept, the RDD Resilient Distributed Data Set, which gives Spark its fault tolerance and in-memory power, but tailored for graph operations, calculating things on vertices and edges.
So you could use it to find influential people in a network or model how things spread.
Perfect examples.
Yeah.
Or optimizing routes, things like that. Complex relationship analysis on a massive scale.
Okay, so it's incredibly powerful across different data types. But a big question for any organization is, how does it fit into our existing systems? Is it flexible?
Very flexible. That's a major plus.
Hmm.
First, languages. It supports Scala, Java, Python, R. So developers and data scientists can often use languages they already know.
That lowers a barrier to entry.
Definitely. And deployment. It's not locked into one ecosystem. It integrates with cluster managers like Hadoop Yarn, Apache Mesos, Kubernetes, or cloud platforms like AWS EC2.
And storage. Does it work with different storage systems?
Oh, yeah. HDFS, Cassandra, HBase, cloud storage like S3 or Azure Blob Storage, Alluxio, pretty much anything you're likely using. You can run it locally on your laptop, on a dedicated cluster, or interactively. Lots of options.
So wrapping up a bit, Spark Core gives us that baseline speed and parallel processing. But the real power comes from its versatility, right?
Absolutely. You've got Spark SQL for structured queries, Streaming for live data, MLlib for machine learning, and GraphX for complex relationships. High-level tools for almost any data job.
And it plays nicely with different languages and environments, making it adaptable, a real go-to solution.
It really is, which leads to the interesting question for you, the listener.
Right. So think about this. If Spark makes complex, real-time analysis so much faster and easier,
Yeah.
what does that unlock?
Consider industries like finance, healthcare, AI development anywhere. Immediate insights are critical. What new possibilities open up when you can process big data almost instantly?
What decisions become possible in real time that just weren't feasible before? Something to ponder.